Bonjour, welcome to Wahsa Deviation Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View, channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning, and we are in our 7th week of our 9-week course. At this point, you definitely should be submitting work for marking as we are wrapping up. Just a reminder that the support questions, the ones with little pencil icon, are practice problems. These are to make sure that you are feeling confident with what it is that you're learning before you hand in your work. So you can decide which ones and how many to do. If you're understanding a concept, it's totally okay to skip questions. You don't have to do them all just because they're there. But I strongly encourage you to do some of the questions and then check your work at the back of the book. So all of the answers are there. Check your work to make sure you're on the right track. Then the key questions, the ones with little key icon, are the marked questions. So these ones you need to submit and you need to do all of them. I'm marking them all, so please do them all. Show your work, your steps, your thinking. This way I can understand what it is that you understand. So please give me as much information as possible so I can help you if you're struggling with something. So how do you actually submit your work for marking? Well, there's 3 methods. The first is to scan your work and send it electronically. If you have a device, you can scan using that device. The Notes app comes with Apple devices and the Google Drive app comes with Android devices. They are fairly straightforward point and shoot processes to scan. But if you do need some support, I've made tech tutorials on my YouTube channel that walk you through step-by-step how to do these. And if that is not clear, let me know and I'm happy to walk you through and we can figure it out together. Then once you have your scanned file, you can send it to me through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you could also send it to me through Facebook Messenger where my name is B-Slate Wahsa. The second method is to drop your work off just in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office and have a small white mailbox next to our side entrance. Put your work in there at any time and I'll get it back to you as soon as possible. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or they can fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B-Slate Wahsa. So you can find me there and friend me or subscribe if that works for you. Then you'll get notifications every time I upload one of our radio Zoom classes. They're all recorded and I upload them shortly after broadcasting so that they're there and you can go over them on your own time when it works best for you. Also on my YouTube channel, there are short videos that explain common errors and confusing concepts so that if you're struggling with something, this is a really good place to go and look first instead of doing a general internet search because it might be a little bit more focused on what you're most likely struggling with. Math is an incredibly visual subject, so I strongly encourage you to access the videos. Just listening to me is going to probably be a bit confusing still, as not being able to see what I'm doing makes it really hard to understand what it is that I'm doing. So watching on Zoom is a great option. You don't have to talk to me. You can just watch. That's fine. Watching the YouTube videos on your own time at your own pace, also a great option. But if neither of those work for you, and it would be helpful for you to have a set of the videos, let me know and I'm happy to send you a copy of them so that you still can access them and get set yourself up for success. So if you have any questions, please reach out and connect with me. I am reaching out to you, but if you don't need to wait until I do that, I have a lot of students. You have one me teacher for this course, so please reach out as needed. Email me at bronwyn.slate@ednec.owen.ca. Send me a Facebook message at bslatewasa. Call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., but I teach from 9 until 11, so that is not a good time to try to get a hold of me. Today, we are continuing with lesson 17. We, in our last session, did the first half, which was looking at measures of central tendency. And the second half, we are looking at standard deviation, which is a measure of variability. So we will continue with that today. So our learning goals for lesson 17 as a whole are that you'll be able to distinguish between mean, median, and mode averages, and you will understand the purpose of the range, variance, and standard deviation for a set of data. Our success criteria, hopefully you have number 1 down, which is you can calculate the mean, median, and mode averages. And today we'll be looking at that you can calculate the range, variance, and standard deviation. But first, as always, let's activate your brain with some mental math. We don't do math minutes in our class. They cause stress and anxiety and don't actually teach anybody anything from my perspective. So instead, we work on developing strategies that we can understand and use friendly numbers that are friendly for us in order to make progress based on what the tools are that we have. So our question today is 316, take away 47. And we're using the strategy that is place value and negative numbers, which is not a strategy that I've ever experienced in elementary school or secondary school, but I find it's kind of an interesting way to think about it. So we're going to take our numbers and break them up into a place value. So 300 plus 10 plus 6 is what 316 is. And then we're going to subtract 40 and subtract 7. So generally we say you can't subtract a lower number from a higher number, or sorry, a higher number from a lower number, but you just get a negative number. So if I do 6 take away 7, I get -1. And if I do 10 take away 40, I get -30. And I have 300 take away nothing, so I have 300. So what this is now telling me is that I have to do 300 take away 30 take away 1 because I haven't taken away enough yet. So 300 take away 30 is equal to 270 and still take away 1. So 270 take away 1 is 269. So 316 take away 47 is 269. So again, this is a really different way of doing subtraction than what we're taught usually in elementary school. The key is that you need to remember that you get negative values. So because lots of people subtract and they do 6 take away 7 equals 1. That is not true because 6 is less than 7, so we don't still have 1 left over, but -1 is true. So you just have to be careful with the negatives. If negatives really confuse you and cause trouble for you, you don't have to use the strategy at all. But if negatives are not painful for you and you want to try it out, it's a really creative strategy for doing subtraction that I quite enjoy. All right, mine's on. What do we need to know for today's lesson? So I just wanted to review quickly, remind you what our measures of central tendency are about that we learned in our last session. If you did not listen to that video, you might want to check it out. If you're already comfortable with mean, median, and mode, you don't have to watch that first part. If you think that you're good to go, that's okay, your call. So remember that to calculate the mean, we add up all the data points and we divide by the total number of data points that we have. The median, we order the data points from lowest to highest, and then we find the middle value. If there's 2 middle values, then we add those up and divide by 2 to figure out what's halfway between. The mode is the value that is the most frequent. So it is possible to have more than one mode if you have more than one value that has the same frequency, that is the highest frequency. Okay, so that's just a reminder of what we've done for the first half of lesson 17. And now let's move on to looking at measures of variability. So first, we're going to understand why variability is important. Why are we even doing this? Why do we care? So we often focus on the mean to summarize the center of a population or a process. This is important because how much data varies is also essential to understand. So not only understanding where the middle is, but how much that information differs from that middle is also important to understand. So a lower variability means a more consistent data set. So here we have a picture where we have all of our data points are really, really close to our line, clustered around it. So that means that most of our data is really consistent. It's really similar. A high variability means the data points are more dissimilar and extreme values become more likely. So things get scattered about and we don't have as much of a pattern that we can necessarily analyze. So understanding your variability helps you to grasp the likelihood of unusual events. So if you have a low variability, it's unlikely that your data is going to vary too much from that mean, median, or mode, but the mean, we're comparing this to the mean. So it's going to vary very limited from that. Whereas if you have a high variability, it's more likely that you're going to have a high chance of it being different, very different than your mean. So we're going to look at 3 different types of variability today. The first is range, and this is on page 10 of your IL booklet. So range is the spread of your data from the lowest to the highest value in the distribution. So all you need to do is subtract the lowest value from the highest value to see how much of an interval there is. So for example, what is the age range of students registered in MBF3C, our course? So we have 21, 36, 31, 26, 20, 25, 37, 34, 22, 28, 27, 47. So if we add all those up and divide by the total number that we have, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students, we get a mean of 28.8. So our mean, our middle age is 28.8. Our range is our highest value, which is 47. Our highest age is 47. Take away our lowest value, which is our lowest age is 20. So our range is 27. So that means that the ages of our students in our MBF3C course range by 27 years. So that's a fairly big difference. So yes, our mean is 28.8, but that is the middle of 27, of a range of 27. So fairly large range. The range is a good representation of data variation if you don't have any extreme values, if you don't have any numbers that are really different from the rest of your numbers. But because it only takes 2 data points, it ignores the rest. If there's outliers, if there's a really, really high value or a really, really low value, that's going to be included. And so it can skew our understanding of the data. It can make it so it's not as clear. So again, if we're looking at this range of our class, so we have 10 points that are really similar. We have 10 points that are between 20 and 36. And then we have 1 point, which is 47. That's an outlier. It's fairly different than the rest of our points. So that distorts our understanding of our data. If we didn't have that outlier, if we ignored it, then our mean would be 27, which is close to 28.8 still, but our range is 16. So that's significantly smaller in terms of how much our numbers vary from our mean. So the range isn't always a great tool if you have outliers. So if we look at these two images, we can see that they have the same range, but really different distribution. So in this first image, we have a lower value of 30 and a highest value of 150. So our range is 120 but for every single data point between 30 and 150, we have one amount. So we have an equal distribution and our range is 120. In the second image, we still have a highest value of 150 and a lowest value of 30. And we have a range of 120 because highest take away lowest. But we have a whole bunch of places that have 0 and we have 9 values at 50. So this range of 120, though true, doesn't really tell us very much about it sort of skews our understanding of our distribution. So this is why we can have the same range, but have really different data, and why range isn't, though it's simple and easy to calculate, isn't necessarily the most useful of tools when we're analyzing data. So what is more precise? We must have something that can make our life give us more information. So this is where standard deviation and variance come into play. So these are two types of what is called absolute measure of variability. They describe how the data is spread out around the mean. So the range doesn't take the mean into account. It just talks about the highest compared to the lowest. So the similarities between variance and standard deviation is that they're always both positive. If the data points are identical, then the standard deviation and the variance will both be 0, because if everything's the same, there is no variability. So standard deviation and variance will both be 0 because it's saying that nothing is changing. The differences are that the variance means how far the numbers are spread compared to the mean average, and the standard deviation is a measure of dispersion of the data values from the mean. So those sound like they are similar, and it can be really confusing, but it's how spread out they are compared to how dispersed they are. So again, we're going to dive into it to figure out what these actually mean, because they seem super similar in that description. So we're going to look at variance first, and this is also on page 10. And this measures how far the data points are spread out from the set of data from the average. The average we're focusing on is the mean. So it's a numerical value, it's a number that describes the variability of observations from its arithmetic mean. It helps determine the size of the data spread. It's expressed in a larger units than the data. It's expressed in squared units, which seems a little strange when we're looking at it. It's not something that makes a lot of sense at our level of understanding statistics. The notation is sigma squared. So this symbol, which is a Greek letter sigma, there we go, looks like a small O with a little line pointing on top, pointing to the right. Also kind of looks like a side image of a whistle as an icon. Could be another way to look at it. So sigma squared is the notation, or it could also be S squared is another option. Okay, so how do we actually solve for the variance? It's a little painful, just so you know. There's a bunch of steps, so let's go through it together slowly. If you need to pause and come back, understandable, just know that there's a bunch of steps and it's a little painful. So what is the variance of student ages in our MBF3C class? So the same data points that we have talked about before, we're using that same data. So first step is to calculate the mean of the data, which we did, which is we're adding up all of our data divided by 11. So the mean, which sometimes people note as X with a straight line above. So it's 28.8. Okay. The second step is to calculate the difference from each data point to the mean. So how far each of the data points are to the mean. So I like to do this in some sort of chart, some sort of organizational tool where I've listed my ages. They're not in order from biggest to smallest. They're just in order of collection. And then I say, okay, well, the mean is 28.8. So I'm going to subtract for each of these, the difference from the mean, how far it is from the mean is I do the subtraction. So 21 take away 28.8 is negative 7.8. 36 take away 28.8 is 7.2. 31 take away 28.8 is 2.2. And we just continue. 26 take away 28.8 is negative 2.8. You keep your negatives. You honor that at this point. We don't just magically drop the negatives. We're thinking about if they're higher or lower. That's important. 20 take away 28.8 is negative 8.8. 25 take away 28.8 is negative 3.8. 34 take away 28.8 is 5.2. 22 take away 28.8 is negative 6.8. 28 take away 28.8 is negative 0.8. 27 take away 28.8 equals negative 1.8. And 47 take away 28.8 is 18.2. So again, this step is sort of tedious. You have to subtract each of them out. You don't have to write them in a chart like this. If you have a different way that you want to do it, you just got to keep track to make sure that you're doing it accurately. Then step 3 is we're going to square each difference. So we're going to take each of our difference from our means and we're going to square each of them. So negative 7.8 squared is equal to 60.84. 7.2 squared is 51.84. 2.2 squared, 4.84. Negative 2.8 squared equals 7.84. Negative 8.8 squared equals 77.44. Negative 3.8 squared equals 14.44. See, as you can see, saying these all out is easy for me to fumble. So you want to make sure you have a system that keeps you in line, keeps you track, because there's lots of data points. The more data points you have, the more pain this is. Finally, 18.2 squared is 331.24. Then next, step 4, we find the sum of the squares. So we add all the squares up, and that's 625.64. And step 5, we divide that sum by the number of data points minus 1. So our variance is equal to 625.64 divided by 11, take away 1. So that is 62.564. And that's how you calculate the variance. So I would strongly encourage you to screenshot this screen if you're watching the video so that you can come back to these 5 steps. Again, using a chart, you don't have to, but figuring out a system that works for you is the best plan because it's really easy to miss data, miss a step, miss a negative. It's just important to keep track. Okay, so then again, let's look at the difference between high and low variance. So what does that, because again, variance, we're still kind of like, what does that even mean? So here we have a distribution and we have someone benefits greatly. So we have somebody just in terms of distribution, we have someone who has a high value and we have others have a really low value. So we have a lot, we have would be a big range and there's a whole bunch of clustered in the middle. So this is high variance because we have a really different experience between some people are going to have a really high values, some people are going to have really low values. So our variance is going to be high because there's more variability in our data. Here in this second image, we can see we have sort of consistent benefit. We have everything sort of clustered around your mean. It's, yes, still you have some higher values and some lower values, but they're fairly closely clustered together. So this is low variance because nothing is going to vary too much. So your number is going to be a lower value. The trick is that how do you know that 62 is 62 point whatever it was. Is that a high value or a low value? And that's what I find tricky with variance, is because it's hard to compare it to our original data set. Standard deviation is much easier to compare to our original data set. Also on page 10 is where it's defined. So our standard is another word for like typical amount that the data points deviate or differ from the mean. So how common is it for a data point to differ by a certain amount? So this measures how much data points differ from the mean of the data set, like I just said. It's a measure of the dispersion of data points relative to their mean. It's calculated by doing the square root of the variance. We've already done all the hard work calculating the variance. So now all we need to do is take the square root and we have our standard deviation. This means that it's expressed in the same units as the original value. So if it's in minutes or meters, it's no longer minutes squared or meters squared like the variance. It's just the single unit. The notation is sigma or s, seeing how we're just doing the square root of the variance, which is sigma squared or s squared. We just do the positive square root, just a note, because we're talking about real things. So we're just talking about the positive square root. So how do we actually solve for the standard deviation? So again, what is the standard deviation of the students' ages in our MBF3C class? Same data set. So first up, we calculate the variance. We have to do those 5 steps that we just did for calculating the variance. When we're calculating the standard deviation, if you've already calculated the variance, you do not need to do the 5 steps all over again. Just use the variance. That is fine. That is how this works. So we know from our last example, the variance is 62.564. So that means that for step 2, we square root the variance. So the standard deviation is equal to the square root of 62.564, which is equal to 7.8, which is approximately 8 years. So what that means in terms of our context of our data is that the majority of our data ranges 8 years from our mean. So our mean is 28.8. So most of our data falls between 8 more than that, which is 36.8. So yes, 47 is outside of that, but most of our data is under 36.8 and so that's the top boundary, and the bottom boundary is 28.8. Take away 8, which is 20.8. And most of our data, our lowest data point is 20. So most of our data falls above 20.8. So again, it gives us a closer range of what makes sense. Even though we kept that outlier in there, it still tells us that most of our data falls in with 8 years of our mean, 8 years in either direction, 8 years above or 8 years below. And that's why it's more useful than the range, is because though it includes the outliers don't have as much of an impact. So here, let's look at standard deviation on a chart in terms of understanding a larger number versus a smaller number. So we have our job satisfaction rating. We have all 3 of these, let's pretend they're companies, have the same mean. They have a mean of 50% job satisfaction. But this blue line has a standard deviation of 5. So that means that most people have a job satisfaction that falls in the range of 5 less and 5 more than the mean. So fall between 45 and 55 is where most people fit. So nobody is like, very few people are like super happy with their job, but very few people are super upset and unhappy with their jobs. So they're clustered around the mean. This red line is a standard deviation of 10. So that means that now for this company, most of the people fall between a range of 40 and 60, sorry, brain freeze for a moment there. So again, we have we don't have as many people who are super like just mediocre, but they don't have a lot of people who are high, but again, we don't have a lot of people who are low. It's a little bit more balanced. And then finally here we have a standard deviation of 20. So that means that most of our people fall between 20 below, which is 30, and 20 above, which is 70. So it's more spread out. We have more people who are really happy with their job, but more people who are really unhappy with their job. So that just tells you more about that company. So again, they all have the same mean. So if we just told them the mean was 50%, that really wouldn't give us the whole picture. But with the standard deviation, we get a lot more information about if people are satisfied with their jobs or not, or if a company really treats everybody the same, or really distinguishes between some people and other people. So that might be a discrimination issue or something like that might needs to be addressed. So now you can do the IL questions on page 11, question 5, which is continuation of, remember, we're still in lesson 17. Okay, so let's do some practice because this is unfriendly. I don't like doing the practice because it's a lot of work, but we're going to do it. All right, number 1, Carmela's monthly gas expenses in dollars for the past year are shown. So that's our data set, is how much Carmela paid for gas per month. We need to calculate the range to the nearest dollar. So the range is easy to calculate. We just do the highest value. I don't know. Spelling did not work. There we go. Highest, take away lowest. So our values are 61, 83, 77, 88, 67, 71, 65, 72, 67, 84, 90, 80. So our highest value is 90. Our lowest value is 61. So our range, 90 take away 60 is 30. So 90 take away 61 is 29. So our range is $29. That is all we need to do. Range, nice and easy, but not super useful, unfortunately. Okay, so calculate the variance to the nearest dollar. So we need to remember all of our steps. Let's see if I can remember them. The first, we need to figure out what our mean is. So the trick with this one is that we our space, we have to be conscious about our space. And I have a limited amount. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points, right? 12 months, that makes sense. So to calculate the mean, we need to add up our data points and divide them by 12. I'm not going to write this out. There's going to be other things that we're going to write out. I'm not writing out the mean. So I'm just going to add them up. So 61 plus 83, 77 plus 88 plus 67 plus 71 plus 65 plus 72 plus 67 plus 84 plus 90 plus 80 equals 905 divided by 12 equals 75.42. So our mean is equal to 75.62, I think is what it was. No, 42. Okay. So that's step 1. Step 2 is to figure out how far each of your points are away from your mean. Now, so what I'm just going to do is I'm going to just write it below each of my points to keep myself organized. Instead of using the Desmos calculator and having to jump back and forth, I'm just going to use my own calculator in my hand. So 61 take away 75.42 is equal to negative 14.42. So I'm not going to draw the arrows. We're just going to list them below them. I'm actually going to make them closer so that we have room. So again, figuring out what works for you is really good to develop a system for these ones because they are organizationally tricky. So 83 takeaway or mean is 7.58. 77 takeaway our mean is 1.58. 88 takeaway our mean is equal to 12.58. 67 takeaway our mean is equal to negative 8.42. Again, you could do this all on Desmos and then do the squared as well at the same time. But if you want to write it out and track it, which means that I can see your work and understand where you've gone wrong, if you've gone wrong, or understand that you understand it if you have not gone wrong, then that is good too. But I also understand that this takes up a lot of space and time to write it down, which personally I don't love. But it is what it is. We're at 72 takeaway error mean. As you can see, I'm squishing over a little bit because that I'm not a computer, so I take up more space. I also have more values or more digits, I guess, opposed to values. Almost there. 2 more to go. Okay, so that is step 2. We now have found the we've now found the difference between each. Okay, step 3, I'm going to do it in a different color to just help keeping us organized and easier to see because it's squashed. So step 3, we're going to square each of our values. So again, I'm just going to do it on my calculator so that I don't have to jump back and forth. So negative 14.42 is squared is 207.94. Then 758 squared is 57.46. Do you want to erase this little line? No. Okay, just trying to keep myself organized, but also not squished. So again, this is why the chart can be good, but drawing a chart can also be annoying. So yes, maybe I'm just rambling, but I'm filling time talking while I am writing down numbers. So 1258 squared is 158.26. Negative 8.42 squared is 70.9. 4.90. For negative 4.42 squared is 19.54. Negative 10.42 squared is 108.58. Negative 3.42 squared is 11.70. Negative 8.42 squared is 70.70. 8.58 squared is 73.62. Almost there. 14.58 squared is 212.58, and 4.58 squared. Why it's not working for me? Come on. Just because it's the last one, it's causing me extra trouble. Is 20.98. Okay. So that is step 2. Then step 3 is we're going to add them all up. So again, I'm just going to do this step on my calculator. I'll show you it this time. So add them all up. Again, if you wanted to do the difference and the squaring all in one go on Desmos, you can. I don't think we're gonna have time for me to show an example of you doing that, but you can figure it out. I believe in you. If you have questions, feel free to ask. So again, the larger the data set, in true statistics, when they're doing really huge data sets, this would all be done by a calculator, or sorry, by a computer, like spreadsheets and things. So 1014.76. So step 4 is 1014.76. And then step 5 is 1014.76 divided by 12, because there's 12 data points, take away 1. So 11 data points. So 92.25 is the variance. So personally, I'm like 92.75 tells me nothing about the range of the variability of the gas, because I'm like, is that a high value or low value? I don't know. But the standard deviation, now we know that the variance is equal to 92.25. We just calculated it. So the standard deviation is equal to the square root of 92.25. So that is, on our calculator, 9.60. So what that's telling us is that the gas varies, the monthly gas cost varies by $9.60. So either it falls in a range of $9.60 higher or $9.60 lower per month than the mean. And to me, that information is more useful than the variance. All right, number 2, A bowling team needs one more person. Eileen and Ingrid are being considered for the spot. They both have the same mean score, but Ingrid's scores have a lower standard deviation than Eileen's scores. Which person should be chosen? Why? So we don't have any numbers. This is just a logical thing to think about and explain. So they have the same mean, means that they generally have the same score, but Ingrid's has a low standard deviation, so has low variation, and Eileen's has high variation. So that means that Ingrid is more consistent because she has low variability. And Eileen is more extreme. So has more highs, but also more lows. So in terms of which person you should choose and why, again, you give me a reason. I don't care which one you pick. If you pick Eileen or Ingrid, as long as you give me a reason that makes logical sense of which one is a better fit for your team. Do you want more consistency? Or do you want someone who is going to potentially give you a bunch of high scores, but also a bunch of low scores? You decide. All right. And unfortunately, we don't have time to calculate the range, variance, and standard deviation of more scores, but we've done it. It's the same process. It's just a slow process. You got to figure out what works best for you. All right, let's consolidate what we've learned today. So this is lesson 17, focusing on the second half, which is called standard deviation, but really should be called measures of variability. So we looked at the range, which is the difference between lowest and highest values. Remember that the outliers can really distort the accuracy of this information and the usefulness. Variance measures how far data points are spread out in the set of data compared to the mean. They're squared units, which means that they're harder to connect to the rest of our data points. And we find it by doing the sum of the squares of the data points distance from the mean divided by the number of data points minus 1. So go through those 5 steps. And then standard deviation is the typical amount that data points differ from the mean. And it's in the same units as the original data, which is how I find it the most useful. And it's the square root of the variance. So you have to do all those steps for the variance, but then you just take the square root and you have the standard deviation. So hopefully, success criteria 1, you can calculate the mean, median, and mode averages, which we focused on in a previous session. And now 2, you can also calculate the range, variance, and standard deviation. You might need to do some practice, but hopefully you can understand the steps involved. So that's the end of our lesson today, lesson 17. So if you have any questions, please reach out and connect with me. This can be confusing, so please reach out. I'm here to support. Give me a call at 807-737-1488, extension 2209, or toll free 1-800-667-3703. You can email me at bronwyn.slate@nnec.on.ca or send me a Facebook message at bslatewahsa. Remember, this lesson and all of our other lessons are up on YouTube under my channel, bslatewahsa, in a playlist called MBF3C. So you can find everything you need there to review all of the work that we've done so far this year. Thank you so much for joining me. I hope you have a lovely day. Which